For number 10, I'm going to go into way less detail than in number 8, so if you desire some more detail, then please go ahead and watch the video that I made for number 8. But for number 10, we know when we look at this equation here, we know it resembles, and it's a child of the parent function y equals 1 over x, which we drew the graph of right up here in the video for number 8. But it does have something different than that number 8 did not have. It has a negative a. So if the a is negative, then that means that we do the same thing with this graph that we have done all year long, and that is to reflect the graph of y equals 1 over x over the line over the x-axis. And so when we take the graph of y equals 1 over x, in fact, we could take the graph of y equals 3 over x. It's the same shape. So that's 3 over x. And then if we replace the a with negative 3 instead of 3, then the graph would be down here. It would reflect this part here, would reflect over the x-axis. And then this part here as well would also reflect over the x-axis. Just like in number 8, we have a vertical asymptote. Right there, the y-axis is the vertical asymptote and the x-axis is the horizontal asymptote. The equations for the asymptotes remain the same, just like in number 8. The equation for the horizontal asymptote is y equals 0. Vertical asymptote, x equals 0. We can see that there is no x-intercept, there is no y-intercept, and the domain remains exactly the same. We can replace x with any real number except for the real number of 0, because you're not allowed to divide by 0. And then the range is a lot easier, by the way, to find the range when you're looking at the graph. So when you look at the graph, you see, oh, the curve is never going to actually hit the x-axis, and so we have the range would be then all the real numbers from negative infinity all the way to positive infinity except for the y equals 0. So that's the range, y such that y does not equal 0. And then for number 12, we've got the same situation going on. It's just a constant over x. It relates to, let me write this down, ha and va. This graph here relates to the graph of y equals 1 over x. Just so, let's put 1 over x in there so again we can illustrate what's going on. This is 1 over x. And then notice it gets close to the origin, and it gets close to each of the axes, but it doesn't actually hit the origin. It doesn't hit either of the axes as well. But the graph of y equals 10 over x is just going to go ahead and be a little bit further out away from the origin. And as far as I'm concerned, as long as you have the right shape and you have the graph in the correct quadrants, I'm okay. I don't need you to be super detailed about, okay, if x is 10, y is 1, x is 1/10, y is 10, or sorry, when x is 1, y is 10. And so I don't need you to draw the graph through those points. I really just want to make sure you understand the shape of the graph, the reason why it's shaped like that, and probably equally as important is that you've got these asymptotes. Asymptotes, again, are lines that the graph approaches, but in general doesn't intersect. And so we have asymptotes. Horizontal asymptote would be the horizontal line here, and the equation for the horizontal line is y equals 0. The vertical asymptote would be, there's only one, x equals 0. The domain, again, is all real numbers x, such that x cannot equal 0, because you can't divide by 0. And the range, again, is all the values of y except for that horizontal asymptote, y cannot equal 0. And there are no x-intercepts and there are no y-intercepts. That's it.